Welcome to my 26th tutoring session in A-level chemistry. In this video, I'll explain the physical and chemical properties of elements in the periodic table. Here are some of the important physical properties of metals and non-metals. Metals are highly malleable in nature. That is to say, they can be hammered into thin sheets. Metals like silver are highly ductile in nature. That is to say, they can be drawn into wires. Now, metals basically are solids. And they have a metallic luster. They reflect the light and hence they shine or glitter. The mercury is an exception. It is a silvery white liquid. Though mercury is a liquid, it still retains its metallic properties. It also reflects light. And because of these unique properties, mercury is suitable for measuring the temperature and pressure. Mercury is used in thermometer to measure the temperature and is used in barometer to measure the pressure. And mercury is also used in sphygmomanometer, which is a device used to measure the blood pressure of an individual. Now, mercury contracts and expands in response to the changes in the temperature and pressure. Now, metals have a high melting and boiling points. For example, the noble metal gold, it has a high melting point. It melts at around 1064 degrees Celsius. It has a high boiling point. It has a boiling point of around 2967 degrees Celsius. While on the other hand, non-metals, they exist in all three states of matter, that is solid, liquid and gases. To mention some examples, now iodine is a solid at room temperature. It is a dark gray solid with low melting and boiling point. Bromine is a reddish orange liquid with a low melting and boiling point. While fluorine and chlorine are gases with low melting and boiling points. Now fluorine is a pale yellow gas, while chlorine is a yellowish green gas. It is very pale in color. Now, non-metals have low melting and boiling points. They are non-lustrous, non-ductile, that is to say, they do not form wires, and they are brittle in nature, and non-metals tend to break or shatter. Non-metals are poor conductors of heat and electricity. Now, what about metals? Now, metals are good conductors of heat and electricity. Now, let me explain this excellent property of metal with respect to copper. Now, in the copper metal, the metal atoms are associated with loosely held valence electrons. The loosely held and freely moving valence electrons are the most important contributing factors that exhibits the metallic properties. So the loosely held and freely moving electrons in case of copper metal, it gives the metal its characteristic properties like good electrical conductivity, good thermal conductivity, malleability, ductility, and metallic luster. Now, the strong electrostatic force of attraction between the positively charged metal ions and the negatively charged delocalized electrons gives the metals its high melting and boiling points, which I have just explained with respect to the noble metal gold. Now, when a silver wire or silver rod is heated, it conducts the heat. So, it is the loosely held and the free moving valence electrons of silver atoms that is responsible for conducting the heat. So, heat is transferred from one end to the other end. So, it is the loosely held and freely moving valence electrons that help in conducting the or in the conduction of heat. And therefore, metals are good conductors of heat. Now, talking about electrical conductivity. So, let me explain with respect to the copper wire or a copper rod. Now, what you see here is a copper wire or a copper rod. Now, here the copper wire is part of a closed electrical circuit, and when a voltage is applied, the loosely held valence electrons of the copper atoms move in a particular direction in an orderly fashion, and that creates the electrical current. So, thanks to the loosely held and freely moving valence electrons that gives the characteristic property to the metals. That is in respect to the conduction of heat and electricity. So, metals are good conductors of heat and electricity because of the loosely held and freely moving valence electrons. Now, here are some of the important chemical properties of metals and non-metals. Now, let me explain the chemical properties of metals and non-metals with respect to sodium and chlorine atom. Now, sodium is a metal while chlorine is a non-metal. Now, this is the electron diagram of sodium in the unreacted form, that is in the zero oxidation state. So, when sodium is in the zero oxidation state, that is in the unreacted form. So, this is the electron structure, and in the electron diagram you find there are 11 protons in the nucleus of sodium atom, 2 electrons in the first shell, 8 electrons in the second shell, and only 1 valence electron in the outermost shell. And chlorine atom in the zero oxidation state, that is in the unreacted form. So, this is the electron diagram or electron structure of chlorine atom in the unreacted form, that is in the zero oxidation state. So, it has 17 protons in the nucleus, 2 electrons in the first shell, 8 electrons in the second shell, and a total of 7 valence electrons in the outermost shell. Now, metals tend to undergo ionization. So, what is ionization? So, ionization is a process involving the formation of ions from the neutral atoms. So, when the neutral atoms lose electrons, they form positive ions, and when the neutral atoms gain electrons, they form negative ions. So, sodium is a metal, so it has a tendency to lose electrons and form positive ions. So, sodium loses its outermost valence electron to the chlorine atom, and after losing its only valence electron in the outermost shell, it forms a electropositive ion. And chlorine, it gains the electron donated by the sodium atom and forms a negative ion. So what makes the sodium atom to lose electron and what makes the chlorine atom to gain electron? So here's the answer. Now sodium, in its unreacted form, the electronic configuration is 281. 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the outermost shell. So after losing an electron, it attains the stable electronic configuration of neon, which is the nearest noble gas in the periodic table. And what about chlorine atom? Now chlorine atom, after it has gained the electron given by the sodium atom, it has attained the stable electronic configuration of argon gas. So before reaction, before accepting the electronic configuration of chlorine is 287, and after accepting the electron, it has attained the stable electronic configuration of argon, that is 288. So argon is the nearest noble gas to the chlorine in the periodic table. So that is why it has attained the stable electronic configuration of argon gas. So the oxidation state of sodium is +1 because it has lost 1 electron, and the oxidation state of chlorine is -1 because it has gained electron donated by the sodium atom. So metals tend to form positive and negative oxidation states. That is metals and non-metals. Now metals tend to form positive oxidation states. In this case, sodium atom, it has lost 1 electron and it forms a positive oxidation state of +1. Chlorine, it has gained 1 electron and has formed or it has taken the negative oxidation state of -1. So metals tend to form positive oxidation states while non-metals tend to form negative oxidation states. So +2 oxidation state will be taken by group 2 elements like magnesium and calcium. +3 oxidation state will be taken by group 3 elements like aluminium. And -2 oxidation state will be taken by group 6 element like oxygen. And -3 oxidation state will be taken by group 5 element like nitrogen. Now moving on to the next important property, reducing and oxidizing property. Now metals are used as reducing agents. Why is that? Because metals can donate electrons easily. So what about non-metals? Non-metals are used as oxidizing agents. Why is that? Because non-metals gain electrons easily. Now metals tend to lose electrons and therefore they are used as reducing agents. So they are very good source of electrons. The metals, because they have tendency to lose electrons easily because of the low ionization energy, they are very good source of electrons and they can be used as reducing agents. For example, sodium and magnesium. So sodium can provide 1 electron while magnesium can provide 2 electrons because sodium is group 1 metal with 1 valence electron and magnesium donates 2 electrons because it is a group 2 element. And metals to the bottom of group 1 are the most powerful reducing agents. Why? Because they donate electrons easily because they have low ionization energy. And what about non-metals? So non-metals, they tend to gain electrons easily and therefore they have oxidizing property. And non-metals to the top of the group 7 are the most powerful oxidizing agent. Why is that? Because group 7 elements, they have a total of 7 valence electrons in the outermost shell and they need just 1 additional electron to complete the octet or to form the full octet. So the driving force for the non-metals, that is group 7 elements, to act as oxidizing agent is that in an atom to gain additional electron to complete the octet, it has its oxidizing property. So group 7 elements gains electron to complete the octet and therefore they act as strong oxidizing agents. Now non-metals to top of group 7, that is fluorine and chlorine. So fluorine is at the top of the group, that is group 7. And chlorine is right below the fluorine atom. And therefore, fluorine and chlorine are the most powerful oxidizing agents. So here in this reaction, you can see chlorine, it just needs one electron to complete the octet. So that is the driving force for the chlorine to gain the additional electron to attain the stable electron configuration of argon. Now, metals, they tend to form basic oxides when they react with oxygen. For example, calcium reacts with oxygen to form calcium oxide. Magnesium reacts with oxygen to form magnesium oxide. And these basic metallic oxides, they react with water to form basic solutions. Like calcium oxide reacts with water to form calcium hydroxide, basic calcium hydroxide. And magnesium oxide reacts with water to form basic magnesium hydroxide. And the metals, they tend to form cations in chemical reactions. So when calcium reacts with oxygen to form calcium oxide, so calcium, after reacting with oxygen, it forms calcium oxide and it forms a cation, that is Ca2 plus. And magnesium, after reacting with oxygen, it forms magnesium oxide. It changes from the neutral oxidation state of magnesium with 0 to 2 plus. This is after losing 2 electrons. So metals generally form cations in chemical reactions. Now one more important example I'd like to mention here, that is sodium metal reacting with water to form basic hydroxide, basic alkaline solution because of sodium hydroxide with the liberation of hydrogen gas. Now this is a highly exothermic reaction and X amount of heat is liberated during the reaction, and utmost care and precaution has to be taken when you are carrying out this reaction. So better to avoid this reaction, not to try this reaction in the lab. And if you are carrying out this reaction for experimental purpose, it has to be done with utmost care under the able and guidance and supervision. So this reaction has to be carried out with able guidance and able supervision. And even metallic oxide like sodium oxide reacts with water to form the basic sodium hydroxide. Now moving on to non-metals. A carbon reacts with oxygen in the air to form carbon dioxide, which is acidic in nature. That is, when it reacts with water, it forms acidic, a compound that is carbonic acid. And in some cases, neutral oxide like carbon monoxide is formed when there is limited amount of oxygen. So when there is limited amount of oxygen, neutral oxide like carbon monoxide is formed during the combustion of carbon-based fuels. So during the combustion of carbon-based fuels, when there is limited amount of oxygen, neutral oxide like carbon monoxide is formed. And non-metals, they form anions in chemical reactions. So for example, calcium reacts with oxygen to form calcium oxide. And after the reaction, the oxygen atom, it has taken 2 electrons from the calcium and has formed a negative ion. And same explanation given for magnesium oxide. So here are some more important chemical properties of metals and non-metals. So metals react with oxygen to form basic metallic oxides. For example, sodium reacts with oxygen to form basic sodium oxide, which is a solid. The solid sodium reacts with gaseous oxygen to form solid sodium oxide. So what about non-metal? So carbon, which is a solid, reacts with gaseous oxygen in the air to form gaseous carbon dioxide. And reaction with water. So this reaction is already explained. So utmost care and precaution has to be taken when you are treating sodium with water, because it is highly exothermic in nature, and X amount of heat is liberated, and hydrogen gas is liberated during the reaction. It's highly flammable in nature. So if you are carrying out this for experimentation purpose, it can be done under able guidance and supervision. And carbon dioxide reacts with water to form acetic oxide. This carbonic acid is formed. So carbonic acid is acidic in nature. So during the combustion of carbon-based fuels, when there's limited amount of oxygen, neutral oxide like carbon monoxide is formed. Now talking about reaction with acids. Now metals react with acids to form salts with the liberation of hydrogen gas. Now metals are highly reactive in nature, and they displace hydrogen from the acids in the form of hydrogen gas. And this liberated hydrogen gas can be utilized for carrying out reduction reactions. It can be used for reducing the nitro group to the amino group. It can be used for converting nitro compounds into amino compounds. So sodium is generally highly reactive in nature. So when you see the electrochemical series, it is right on top of the hydrogen, and therefore it displays hydrogen ion in the acids. And metals react with hydrogen gas to form metal hydrides. For example, sodium reacts with hydrogen gas to form sodium hydride. Now sodium is a metal here and hydrogen is a non-metal. So what is the basic nature of a metal? It tends to lose electrons. And non-metal, it tends to gain electrons. So in this reaction, sodium donates 1 electron, while hydrogen being a non-metal, it gains 1 electron. And therefore the oxidation number of sodium is +1 and oxidation number of hydrogen is -1 after the reaction. So metallic sodium reacts with gaseous hydrogen to form sodium hydride, which is a solid. Now moving on to the next important reaction, reaction with salts. So metal reacts with salts leading to a displacement reaction. Generally, it is a redox reaction. Now, for example, metallic iron reacts with copper sulfate to form ferrous sulfate with the precipitation of copper in the form of solid. So iron in the solid form reacts with copper sulfate solution, leading to formation of ferrous sulfate solution, the removal of copper in the process. Now here in the electrochemical series, now iron is right on top of copper. So iron is right on top of copper in the electrochemical series, therefore it is more reactive than copper, and therefore it displaces copper from its salt solution. And during this displacement reaction, iron loses 2 electrons while copper gains 2 electrons. So it is a redox reaction. So iron losing 2 electrons, it forms ferrous ion. So it is converted into ferrous sulfate, and copper, it gains 2 electrons and cupric ion is reduced to solid copper. And talking about reaction with metals. Now metals also react with other metals, or to say metals can also be combined with other metals. So what is an alloy? Now alloy is a mixture of 2 or more elements, or alloys are formed when you mix 2 or more, or when you combine 2 or more elements. Now for example, steel is an alloy of iron and carbon. So steel can be formed when iron is combined with carbon, and steel can also be prepared by combining iron with not only carbon but also with other elements like tungsten and chromium. So what is the difference between these 3 different probabilities? So steel is formed when you combine iron with carbon. Steel is formed when you combine iron with carbon and tungsten. Steel is also formed when you combine iron with carbon, tungsten and chromium. So difference lies in the hardness. So there is variation in the hardness of these three steel materials, which varies in the number of elements that are combined, leading to formation of the alloy, that is steel. And non-metals like chlorine, they combine with metals like sodium to form ionic compound, that is sodium chloride. Now talking about reaction with non-metals. So sodium being a metal, it reacts with non-metal like chlorine to form ionic compound, that is common salt sodium chloride. So coming to the non-metals. So this is one of the important property exhibited by non-metals, that is it exhibits covalency. So non-metals exhibit covalency, which is an important property of non-metal. So covalent compounds are formed by sharing of electrons between the atoms involved in bond formation. A covalent bond is formed by mutual sharing of electrons between the atoms involved in bond formation. The atoms can be either equally shared or unequally shared. So when the electrons are equally shared, it leads to non-polar covalent compounds. When it is unequally shared, it leads to polar covalent compounds. Like for example, monoatomic molecules like hydrogen, chlorine, oxygen and nitrogen. They are non-polar in nature because electrons are equally shared between the atoms involved in bond formation. So both the atoms in all these four examples are identical with same electronegativity, and therefore they are non-polar. And one good example of polar covalent compound will be the universal solvent water. And why water is polar in nature? Because the oxygen atom is more electronegative than hydrogen atom. So oxygen atom is covalently bonded to two hydrogen atoms. And because of greater electronegativity of oxygen atom, it pulls the shared pair of electrons closer to itself. And thereby the oxygen atom gains a partial negative charge while the hydrogen atoms gain a partial positive charge, making it a polar covalent compound. Don't forget to subscribe my channel, share, like, comment and watch my full videos. Thank you so much for watching my video. I hope you enjoyed it. I'll meet you in my next interesting tutoring session.